So today we are going to discuss exercise 1.2, question number first. In this question we have to express the given numbers as the product of its prime factors. Okay, so simply we have to find its prime factors. First part is 140. So for finding its prime factor, firstly I will check for 2, as the smallest prime number is 2. So if I divide 140 by 2, then I will get 70. Again, this is divisible by 2. I will get the answer 35. Now we know that 35 is not divisible by 2. So we check it for 3. But it is also not divisible by 3. Then we move towards 5. Okay. So we see 5 7 is 35. Okay. Now this 7 is itself a prime number, so it will be divisible by 7 only. So factors of 140 are 2 into 2 into 5 into 7. So in this way you have to complete other parts also. Moving to second part, that is 156. Now firstly it is divisible by 2 78 times. Then this is again divisible by 2 39 times. Then we know that 39 is not divisible by 2, so we will divide it through 3. Now we get 13, which is itself a prime number, so we will use 13 here again. So the prime factors of 156 are 2 into 2 into 3 into 13. Now moving to third part. Third part we have 3825. So we know that it is not divisible by 2 as we have 5 in one's place. So we will try it with 3. Now we get 1275 because 3 ones are 3, then 3 twos is 6, 2 carry, 3 sevens are 21, 1 carry, 3 fives are 15. Now again it is divisible by 3, 3 fours are 12, 3 twos is 6, 1 carry, 3 fives are 15. Okay. Now this is divisible by 5. 5 eights are 40, 2 carry, 5 fives are 25. Now again it is divisible by 5. 5 ones are 5. Now 3 carry, 5 sevens are 35. Now 17 is also a prime number, so it is only divisible by 17. Okay. So factor of 3825 are 3 into 3 into 5 into 5 into 17. Now moving to fourth part, we have 5005. Now it is divisible by 5. 5 ones are 5 and 0 will come as it is. Now again 5 ones are 5. Now it is divisible by 7. 7 ones are 7. 3 carry. 7 fours are 28. 2 carry. 7 threes are 21. Now it is divisible by 13. 13 ones are 13. 1 carry. 13 ones are 13. Now 11 is also a prime number. 11 ones are 11. So factors of this number are 5 into 7 into 13 into 11. Now fifth part of question number 1, 7429. So it is divisible by 17. 437 is the answer. Now again this number is only divisible by 19. So we get 23. Now 23 is itself a prime number, so we will divide it by 23. So factor of this number are 17 into 19 into 23. Now moving to second question. Question of this exercise says that find the LCM and SCF of the following pairs of integers and verify that LCM into SCF is equal to product of two numbers. In this question we have to firstly find the LCM of these two numbers, then their SCF, and then we have to show that the product of LCM and SCF of these two numbers is equal to product of these two numbers. Okay. So firstly, for finding SCF, I have taken 26, so it will come in 2. It will be divisible by 2. 2 13s are 26. Now 13 is a prime number, so 13 ones are 13. So its factors are 2 into 13. Similarly, 91 will be divisible by 7. 13. Now 13 is also a prime number, so we will divide it by 13. So factor of 91 are 7 into 13. Now we can see that these both have only 13 as common factor. So SCF will be 13 and LCM will be multiplication of all these three different numbers. Okay. 13 into 2 into 7. If you don't know how to find LCM in this way, so you can individually separately find the LCM. Okay, now I have get the SCF and LCM of these two numbers. Now I will multiply these. Now I have to prove that LCM into SCF is equal to product of these two numbers. So taking LHS, that is left hand side of this equal, I have LCM into SCF. Now I will solve it. 182 was the LCM and 13 was the SCF. After multiplying this, I get 2366. Now solving the RHS side, that is product of these two numbers, that is 26 into 91. Again I get 2366. So both LHS and RHS are equal, hence I have verified this. Okay. In the similar way, we will solve other parts of this question. Second part, I have 510 and 92 as two numbers. I have find their factors individually. Now in these both two, I have only 2 as a common, so SCF will be 2 and LCM is 2 into 3 into 5 into 17 into 2 into 23. Now I have to find the product of LCM and SCF, that will be 23,460 into 2, which will come out to be 46,920. Similarly, I will find the product of these two numbers, that is 510 into 92, which will come out to be 46,920. Hence, both LHS and RHS are equal. Hence, my question is proved. Moving to third part, I have 336 and 54 as two different numbers. Now I have find their factors individually. Now SCF will be the common factor, that is 2 and 3. So 2 into 3, that is 6, will be the SCF. Now moving to LCM, I have get LCM as 2 into 2 into 2 into 2 into 3 into 3 into 3 into 7. How we are getting the LCM? We will see different numbers, like which factors are repeated in both of them, we will take it only once, and those which are not repeated, we will also take them. Like here 2 and 3 were repeated, so we take 2 and 3 only once and rest are taken. Okay, so LCM is 3024. Again I will find the product of LCM and SCF, which is 3024 into 6, that is 18,144. Now the product of these two numbers, that is 336 into 54, which is equal to 18,144. Again LHS and RHS are both equal, so hence verified. Moving to third question, find the LCM and SCF of the following integers by applying the prime factorization method. We have to find now the LCM and SCF of these numbers by prime factorization method, which we used in the previous question. Okay. First part, I have 12, 15 and 21 as three different numbers. I have find their factor through prime factorization method. Now I will write their factors in this form. Now I can see 3 is common in all of them. So 3 will be their SCF. SCF is 3. Now moving to LCM. I have said we will take all the numbers. Okay, now for LCM, I have 2 into 2 from first part. Okay, and 3 also from the first part. Now moving to second number, that is 15. I have already taken this 3 in the first part. Okay, so the repeated factor will not be repeated in LCM. Now moving to 5, here is 5 also, so we get 5 in LCM. Now for this 3, again this 3 is common in both these 3. So I have already taken it, so I will not take it again. Okay, now I will take this 7. So the LCM of these two numbers is 2 into 2 into 3 into 5 into 7. Okay, that is 420. In the similar way, you have to solve other parts of this question. The second part, I have numbers 17, 23 and 29. So I can see all these three are prime numbers, so they don't have anything common rather than 1. So the SCF will be 1 and LCM will be the multiplication of these three numbers, that is 17 into 23 into 29. So SCF is 1 and the LCM is multiplication of these three numbers, that is 11,339. Moving to last part of this question. I have 8, 9 and 25 as numbers, and these are their factors. So for SCF we have nothing in common, so SCF will be 1, as only 1 is common in both of these three numbers. And for LCM, as there is nothing in common, so simply the multiplication of all the prime factors of this number will be the LCM, that is 2 into 2 into 2 into 3 into 3 into 5 into 5, that is 1800 is the LCM. Question number 4. The SCF of 306 and 657 is given as 9, and we have to find the LCM of these two numbers. The SCF is given as 9, we have to find the LCM, and the first number is 306 and let the second number is 657. Then we already know that LCM into SCF, that is product of LCM and SCF of a number, is equal to product of these numbers. Okay, so we will simply follow this rule. Now we have to find the LCM, so we will write here LCM, and SCF is already given. Now the product of these two numbers, here the 9 is in multiplication, so on moving to another side of equal, it will convert into divide. On solving this equation, now this 9 will cut this 306 as 34 times. I have to only multiply these two numbers, and my answer is 22,338, and this is the LCM of these two numbers. Question number 5. In this question we have to prove any number which can be expressed in the form of 6 raised to the power n can end with 0. We have to check this, okay, rather it ends with 0 or not, where n is any natural number. It can take values as 1, 2, 3, 4 up to 9, up to n. Okay, for any number to end with 0, there is a rule that it must contain a factor 2 into 5. Okay, as 2 into 5 is equal to 10. So if any number is ending with 0, so it will definitely contain a factor 2 into 5. But as we can see, if we express any number in the form of 6 to the power n, we can express it as 2 into 3 whole to the power n. So we know that if we do the prime factorization of this number, we will never get 2 into 5 as factor. So this number can't be end with a digit 0. So it can't be end with 0. So moving to next question. In question number 6, we have to explain that the number 7 into 11 into 13 plus 13 and another number 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Okay, for this you have to firstly understand that what are composite numbers. So composite number are those numbers which are not prime numbers. Okay, that is, they come in the table of themselves in one's table and also in the table of any other number. So they are known as composite number. So now the first number was 7 into 11 into 13 plus 13. As I can take 13 common from both these two terms. Now in first term I will left with only 7 into 11 plus in second term there will be only 1. On solving this, 7 into 11 will be 77 plus 1, that is 78. Now multiplying these two numbers, I will get 1014. So it can easily be proved that it is a composite number by finding its factors. Similarly, for second number, we will do the same process. In these two numbers, we can take 5 as common. Now we have to solve this equation. We have to simply just multiply these numbers, then add 1 to it. So again, this number is also a composite number. So moving to the last question of this exercise. The seventh question, there are two persons, that is Sonia and Ravi. Both are running around a circular path. Okay, if they started together at the same time, they both take different times to complete a circle. So we have to find that after how much time they will meet again at the starting point. Suppose this is a circular track. Both Ravi and Sonia start from this point. They run together, but one is taking less time and another is taking more time. So we have to tell that when they will again meet at the starting point. Okay? These type of question you have to simply find the LCM of these two numbers and you will get your answer. First one was taking 18 minutes and second one was taking 12 minutes. So we will just find the LCM of these two numbers. As these two are divisible by 2, I will take 2 here. Now these two numbers, again 6 is divisible by 2 but 9 is not divisible by 2. So I will copy this number as it is and here it will come 3. Now these two numbers are not divisible by 2, so we will take 3 here. 3 3s are 9 and 3 1s are 3. Now again this 3 is divisible by 1. LCM of these two numbers is 2 into 2 into 3 into 3, that is 36 minutes. So these two both will be meet again at the starting point after 36 minutes.